Okay, now we'll start with another chapter of derivatives which is called as parametric functions. Okay, let's see this. Now what is parametric functions? Where you have multiple variables. When you have multiple variables, that is parametric functions. For example, let's see a sum. They've given you that x is cos of log t, y is log of cos t. You have to find out dy by dx. Let's see how do we do this sum. First of all, x is cos of log t. Since the variable on the right hand side is t, you will be differentiating with respect to t. So you will say differentiate with respect to t. So d by dt of x is d by dt of cos of log t. Right? Cos u minus sin u d by dx of u. So d by dt of log t. So this is going to be minus sin log t. D by dt of log t is 1 upon t. Now similarly we will call this is my dx by dt. We will call this as my equation 1. Y is equal to log cos t. Differentiate with respect to t. Right? So you will get d by dt of y is d by dt of log cos t. D by dt of log u is 1 upon u d by dt of cos t. D by dt of cos t is minus sin t. So this is going to be minus tan t. Now I can say that dy by dx is nothing but dy by dt upon dx by dt. We have already found out dy by dt here. Call this as equation 2. So that means from 1 and 2 I can therefore say that dy by dx is equal to dy by dt minus tan t upon minus sin log t into 1 upon t. Minus and minus gets cancelled, so you will get dy by dx is t tan t. Denominator of denominator becomes numerator, so t tan t upon sin log t. Right? That's the sum. Right? So do we get how we are supposed to solve parametric function? Let's move on ahead. Let's move on to the next sum. X is equal to a cos cube t, y is equal to a sin cube t. You have to find out dy by dx. So let's see how do we do this. X is equal to a cos cube t can be written as cos t the whole cube. Differentiate, the variable on the right hand side is t, so differentiate with respect to t. So d by dt of x is d by dt of a cos t the whole cube, a as it is, u raised to n, d by dx of u raised to n, n u n minus 1 d by dx of u, so d by dt of cos t. So this is going to be 3a cos square t. D by dt of cos t is minus sin t, so you will get dx by dt is minus 3a sin t cos square t. Now similarly I can say y is equal to a sin cube t. Differentiate with respect to t. So in that case this can be written as d by dt of y is a d by dt of sin cube t can be written as sin t the whole cube. Same formula. u raised to n, n u n minus 1 d by dt of sin t. So you will get dy by dt is a 3a sin square t. D by dt of sin t is nothing but cos t. Once you have this, once you know the value of dx by dt and dy by dt, you can find out dy by dx. Dy by dx is nothing but dy by dt upon dx by dt. Dy by dt is 3a sin square t cos t. Dx by dt is minus 3a sin t cos square t. 3a gone, square and sin t gone, cos t and square gone. So that leaves you with sin t upon cos t, which is nothing but tan t. Fine. Let's move on to the next one, guys. X is equal to sin square theta, y is equal to tan theta. You have to find dy by dx at theta is equal to pi by 4, right? Let's see the sum. X is equal to sin square theta can be written as sin theta the whole square. Differentiate with respect to theta. So you will get dy d theta of x is dy dx of u square is 2u dy d theta of sin theta. Dy dx of u square is 2u dy dx of u. So you will get dx by d theta is 2 sin theta d by d theta of sin theta is cos theta, right? Leave that there as it is. Next, I can say y is equal to tan theta. Differentiate with respect to theta. So you will get dy by d theta is d by d theta of tan theta. D by d theta of tan theta is nothing but sec square theta. Right? Now, I can therefore say that dy by dx is nothing but dy by d theta upon dx by d theta, which can be written as sec square theta upon 2 sin theta cos theta, right? But they have given you that the value of theta is pi by 4, but theta is pi by 4. Therefore, dy by dx is equal to sec square pi by 4 upon 2 sin pi by 4 cos pi by 4. Now, pi by 4 is 45, cos 45 is 1 by root 2, so sec 45 will be root 2, sec square 45 will be 2, sin 45 1 by root 2, cos 45 1 by root 2, 2 and 2 gets cancelled. Root 2 into root 2 is 2. Denominator of denominator becomes numerator, so the answer is 2. Right? Let's move on to the next one, guys. X is equal to a theta minus sin theta, y is equal to a 1 minus cos theta. You have to find out dy by dx, right? Let's see this. X is equal to a theta minus sin theta. Differentiate with respect to theta. So you will get d by d theta of x is d by d theta of a theta minus sin theta. A is constant, comes out as it is. D by d theta of theta is 1. D by d theta of sin theta is cos theta. Next, I can say y is equal to a 1 minus cos theta, differentiate with respect to theta, so you will get d by d theta of y is d by d theta of a 1 minus cos theta. Now a as it is, d by d theta of 1 is 0, d by d theta of cos theta is minus sin theta. So that minus sign multiplies here to give you sin theta. So this is a sin theta, right? Now you can say dy by dx is nothing but dy by d theta upon dx by d theta. So this is going to be equal to dy by d theta a sin theta upon dx by d theta is a 1 minus cos theta. A and a gets cancelled. Use sum multiple here. If I use sum multiple here, d by d theta of sin theta is 2 sin theta by 2 cos theta by 2 upon this is sin theta, sum multiple is 2 sin theta by 2 cos theta by 2. 1 minus cos theta is 2 sin square theta by 2. So 2 and 2 gets cancelled, sin theta by 2 and square gets cancelled. Cos upon sin is nothing but cot theta by 2. The answer is going to be cot theta by 2. Right? Let's move on to the next one, guys. X is equal to a cos t minus plus t sin t, and y is equal to a sin t minus t cos t. You have to find out dy by dx, right? Now I can say x is equal to a cos t plus t sin t, differentiate with respect to t. So d by dt of x is d by dt of a cos t plus t sin t. So a as it is, d by dt of cos t is minus sin t, plus here you will use the uv formula, u and v. There is multiplication between two terms, therefore you will use the uv formula. So this is v derivative of u plus u derivative of v, right? So this is going to be a minus sin t plus sin t plus t, d by dt of sin t is cos t, cancel, this is at cos t. Next I can say y is equal to a sin t minus t cos t, differentiate with respect to t. So you will get d by dt of y is d by dt of a sin t minus t cos t. A as it is, d by dt of sin t is cos t, minus, you will use the uv formula again. This is going to be v derivative of u plus u derivative of v, right? So this is a cos t minus cos t plus into minus minus t plus into minus minus, d by dt of cos t is minus sin t, so this will become plus sin t, right? Cos t and cos t gets cancelled, so this is at sin t. Once you have this, then you can say that dy by dx is nothing but dy by dt upon dx by dt. Dy by dt you found out is at sin t upon dx by dt you found out as at cos t, which is nothing but tan t, right? Next, let's move on to the next one, guys. y is equal to a raised to t plus 1 upon t and x is equal to t plus 1 upon t the whole raised to a. You have to find out dy by dx. Now y is equal to a raised to t plus 1 upon t. Variable on the right hand side is t, differentiate with respect to t. dy dt of y is dy dt of a raised to t plus 1 upon t. Now this you will use the formula a raised to u. So this is going to be a raised to u log a dy dx of u. So this is going to be dy dt of t plus 1 upon t. So this is a raised to t plus 1 upon t log a dy dt of t is 1 plus dy dt of 1 upon t is minus 1 upon t square. Right? Now once you have dy by dt, now let's move on to x. X is t plus 1 upon t the whole raised to a. Differentiate with respect to t. So you will get dy dt of x. Here you will use the formula u raised to n, n u n minus 1 d by dt of t plus 1 upon t. So this is a t plus 1 upon t the whole raised to a minus 1. d by dt of t is 1 plus d by dt of 1 upon t is 1 up minus 1 upon t square. Now I can find out dy by dx. dy by dx is nothing but dy by dt upon dx by dt. Now this can be written as dy by dt is nothing but a raised to t plus 1 upon t log a 1 minus 1 upon t square upon dx by dt a t plus 1 upon t the whole raised to a minus 1 into 1 minus 1 upon t square. 1 minus 1 upon t square in the numerator and denominator gets cancelled. So your final answer is t plus 1 upon t log a upon a t plus 1 upon t raised to a minus 1. Fine. Let's move on to the next sum, guys. X is equal to e raised to cos 2t, y is equal to e raised to sin 2t. You have to prove that dy by dx is equal to minus y log x upon x log y. X is equal to e raised to cos 2t. Since there is a variable in the indice, you will take log on both sides. If I take log on both sides, I will get log x is equal to log of e raised to cos 2t. Right? Whatever is the number in the indice comes before log. So you will get log x is cos 2t log e. We know the value of log e to be 1, so this is going to be cos 2t. Differentiate with respect to t. So you will have d by dt of log x is nothing but d by dt of cos 2t log u 1 upon u d by dt of x u log u 1 upon u d by dx of u, right? Cos u minus sin u d by dx of u. So therefore you will get this as dx by dt, take the x on the other side, minus x sin 2t d by dt of 2t is 2. Okay, next I have y is equal to e raised to sine 2t. Variable in the indice, take log on both sides. If I take log on both sides, I will get log y is sine 2t log e. I have brought the indice before the log. We know that the value of log e is 1. So sine 2t. Differentiate with respect to t. If I differentiate with respect to t, this is going to be 1 upon y d by dt of y sine u cos u d by dt of 2t. So you will get dy by dx is nothing but y goes up here, cos 2t d by dt of 2t is 2, right? Next, dy by dx is nothing but dy by dt upon dx by dt. dy by dt is y cos 2t into 2 upon dx by dt. dx by dt is minus x sine 2t into 2. 2 and 2 gets cancelled. This is minus y upon x cos 2t upon sine 2t. Now if we look up in the sum, cos 2t is nothing but log x. I can substitute the value of cos 2t as log x. So this can be written as minus y upon x. Instead of cos 2t, I will write log x. Similarly, when we look up in the sum, we will get sine 2t is log y. So instead of sine 2t, I will write log y. And this is exactly what I have to do. Minus y upon x, log x upon log y. Right? That's the answer. Next, let's move on to the next sum, guys. Now, so far we had been differentiating with respect to x or y. Now, let us try to differentiate with respect to a function. Differentiate e raised to x sin x with respect to tan inverse of x. Okay. Now we are differentiating a function with respect to another function. First of all, let u be equal to e raised to x sin x. Differentiate with respect to x. So you will get d by dx of u is d by dx of e raised to x sin x. So you will get du by dx e raised to u is e raised to u d by dx of u x sin x. This is e raised to x sin x. Here I can use the uv formula. So this is v derivative of u plus u derivative of v. So this is e raised to x sin x. Sin x as it is, d by dx of x is 1 plus x. D by dx of sin x is cos x, right? So you will get e raised to x sin x plus x cos x. Similarly, I can say let v be equal to tan inverse of x. Differentiate with respect to x. So you will get d by dx of v is d by dx of tan inverse of x. So tan inverse of x is nothing but 1 upon 1 plus x square. But let us look at the sum again, guys. It says that differentiate e raised to x sin x with respect to tan inverse of x. That means I have to differentiate u with respect to v. That means I have to differentiate u with respect to v. So du by dv can be written as du by dx upon dv by dx, right? If I substitute these values, du by dx is e raised to x sin x plus x cos x upon dv by dx can be written as 1 upon 1 plus x square. So your final answer is 1 plus x square e raised to x sin x plus x cos x. Fine, do we get this thing here? Next, let's move on to the next one, guys. Differentiate log of 1 plus x square with respect to tan inverse of x. Similar to the previous sum, you will say let u be equal to log of 1 plus x square, differentiate with respect to x. So you will get d by dx of u is d by dx of log of 1 plus x square. So you will get du by dx log u 1 upon u d by dx of u, right? So in which case you will get this as du by dx is 1 plus x square in the denominator, d by dx of 1 is 0 and d by dx of x square is 2x. Now let v be equal to tan inverse of x, differentiate with respect to x. So you will get d by dx of v is d by dx of tan inverse of x, which is nothing but 1 upon 1 plus x square. You have to differentiate log of 1 plus x square with respect to tan inverse of x. That means you have to differentiate u with respect to v, which can be written as du by dx upon dv by dx. Du by dx is nothing but 2x upon 1 plus x square. dv by dx is 1 upon 1 plus x square, right? So this is going to be equal to 2x, because 1 plus x square and 1 plus x square will get cancelled. Your final answer is going to be 2x. Let's move on to the next one, guys. Differentiate 1 minus x square upon 1 plus x square with respect to 2x upon 1 plus x square, right? Now, first thing that you need to do is think which formulas are in this format. The submultiple formulas are in this format and the multiple submultiple formulas are in this format. So you would say let x be equal to tan theta. Let u be equal to 1 minus x square upon 1 plus x square. 1 minus, I have assumed the value of x to be tan theta. So this becomes 1 minus tan square theta upon 1 plus tan square theta. 1 minus tan square theta upon 1 plus tan square theta is nothing but cos 2 theta. Now differentiate with respect to theta. If I differentiate with respect to theta, I'll get d by d theta of u is d by d theta of cos 2 theta. Cos u is minus sin u d by d theta of 2 theta. D by d theta of 2 theta is going to be 2, so minus 2 sin 2 theta. Same way, let us assume that v is equal to 2x upon 1 plus x square. But we have assumed the value of x to be tan theta, so this is 2 tan theta upon 1 plus tan square theta. 2 tan theta upon 1 plus tan square theta is nothing but sin 2 theta. Differentiate with respect to theta. So d by d theta of v is d by d theta of sin 2 theta. D by d theta of sin u. Sin u is nothing but cos u d by d theta of 2 theta. So this is 2 cos 2 theta, because d by d theta of 2 theta is going to be equal to 2. They will ask you to differentiate the first term with respect to the second term. That means I have to find out du by dv. Du by dv is du by dx upon dv by dx. Du by dx is minus 2 sin 2 theta upon 2 cos 2 theta. 2 and 2 gets cancelled. This is minus tan 2 theta. But tan 2 theta is nothing but 2 tan theta upon 1 minus tan square theta by using multiple angles. But right in the beginning we had assumed the value of tan theta. We had assumed the value of tan theta to be x. So resubstitute the value. So this is going to be minus 2x upon 1 minus x square. So the answer is going to be minus 2x upon 1 minus x square. Let's move on to the next one, guys. U is equal to 2bt upon 1 plus t square, and V is equal to a 1 minus t square upon 1 plus t square. You have to find out du by dv. Same logic that we used in the last term. Let t be equal to tan theta. Therefore, I will get u is equal to, take the b outside. So you will get this as 2 tan theta upon 1 plus tan square theta. What did I do? I substituted the value of t as tan theta. B is a constant, comes out 2 tan theta upon 1 plus tan square theta, which is nothing but sin 2 theta. Differentiate with respect to theta. So d by d theta of u is d by d theta of b sin 2 theta. B as it is sin u cos u d by d theta of 2 theta. D by d theta of 2 theta is going to be 2, so this is 2b cos 2 theta. Similarly, V is given to you as a 1 minus t square upon 1 plus t square. Substitute the value of t, so 1 minus tan square theta upon 1 plus tan square theta. But 1 minus tan square theta upon 1 plus tan square theta is nothing but cos 2 theta. Multiple angles. Now differentiate with respect to theta. Differentiate with respect to theta. So you will get d by d theta of V is a d by d theta of cos 2 theta. A d by d theta of cos 2 theta is nothing but minus, I'm writing a minus sign here, minus sin 2 theta d by d theta of 2 theta. D by d theta of 2 theta is going to be 2. So this is minus 2a sin 2 theta. They have asked you to differentiate the first term with respect to the second term. Therefore, du by dv is du by d theta upon dv by d theta. Du by d theta you found out as 2b cos 2 theta upon dv by d theta we found out as minus 2a sin 2 theta. Right? This and this gets cancelled. Now, guys, if I look at my original equation, see this minus b upon a, I will leave it as it is. Can you just look up at the original equation? We had said that u is equal to b sin 2 theta. That means sin 2 theta can be written as u upon b from here. Look at this, guys. In the denominator I have sin 2 theta, which can be written as u upon b. Similarly, if we look at this equation, v is equal to a cos 2 theta. Therefore, cos 2 theta can be written as V upon A. Cos 2 theta can be written as V upon A. Denominator of denominator becomes numerator. So this will become minus B square. This and this gets multiplied here. A square B upon U. Right? So the answer is going to be minus B square upon A square V upon U. Let's move on to the next one, people. Differentiate sine inverse of 2x upon 1 plus x square with respect to cos inverse of 1 minus x square upon 1 plus x square. Right? Think about multiple submultiple formulas. Let x be equal to tan theta. Let u be equal to sine inverse of 2x upon 1 plus x square. First term I am assuming as u. We substitute the value of x. So sine inverse of 2 tan theta upon 1 plus tan square theta. This is sine inverse of 2 tan theta upon 1 plus tan square theta is nothing but sine 2 theta. Sine inverse and sine gets cancelled, so this is 2 theta. Differentiate with respect to theta. So you will get dy d theta of u is d by d theta of 2 theta, which is going to be equal to 2. Similarly, let v be equal to cos inverse of 1 minus x square upon 1 plus x square. We have assumed the value of x to be tan theta. So this will be 1 minus tan square theta upon 1 plus tan square theta. 1 minus tan square theta upon 1 plus tan square theta is nothing but cos 2 theta. Cos inverse and cos gets cancelled, which is nothing but 2 theta. Differentiate with respect to theta. So you will get dv by d theta is nothing but d by d theta of 2 theta, which is nothing but 2. Once you have this, now you can solve the sum now. You can say that du by dv is nothing but du by d theta upon dv by d theta. Du by d theta you found out as 2, dv by d theta is 2, answer is 1. Right? Let's move on to the next sum. The last sum to finish this chapter. Differentiate tan inverse of 3x minus x cube upon 1 plus 3x square with respect to tan inverse of x. Same thing, here we will be using triple angle formula. Let x be equal to tan theta. Let u be equal to tan inverse of 3x minus x cube upon 1 plus 3x square. So u is equal to tan inverse of 3 tan theta minus tan cube theta upon 1 plus 3 tan square theta. I substituted the value of x. Now this 3 tan theta minus tan cube theta upon 1 plus 3 tan square theta is nothing but tan 3 theta. Right? Tan inverse and tan gets cancelled, that is 3 theta. Differentiate with respect to theta. So you will get du by d theta is d by d theta of 3 theta, which is nothing but 3. Let v be equal to tan inverse of x. but we have assumed the value of x to be tan theta. So tan inverse and tan gets cancelled, that is theta. Differentiate with respect to theta. So you will get dv by d theta is d by d theta of theta, which is nothing but 1. Once you have this, you can find out du by dv, which is nothing but du by d theta upon dv by d theta, which is nothing but 3 divided by 1 t. That will be the answer for the sum. This finishes parametric functions. Right? Let's stop here for the day. Thank you.